Hello, I'm Charlie Alpers. I'm one of the renal pathologists involved in KPMP, and I've been involved in KPMP right at the outset and even in some of the planning meetings before the KPMP formally became an entity. I've had the opportunity to see the evolution of how we use renal biopsies to take care of patients with renal disease. And in all candor, I have to say that while we were doing amazing things with renal biopsies 30 years ago, the amount of progress has not been great. So my role in KPMP is to reinvent some aspects of the kidney biopsy so that we can get more information from them. So in KPMP, I participate both in the interpretation of biopsies. I participate in the integration of the clinical information that we are gaining from our patients with their biopsies. I am participating in systems in which we convert the pathology specimens that constitute a renal biopsy into digital images, now made possible by modern technologies that can then be utilized partly using approaches like artificial intelligence to better identify information in kidney biopsies that wasn't previously available to be ascertained by humans without such tools. Finally, my job as a renal pathologist is to integrate all of the wonderful molecular and protein information that we're getting from renal biopsies that is performed by all of the tissue interrogation sites within the KPMP. I've been a renal pathologist for over 30 years, and I've participated in numerous clinical studies, and I'm also a basic scientist and have a basic science lab. And I've been able to see the evolution of how much knowledge we have gained about kidney disease, and it is extraordinary. We have learned a lot about the various cells that cause kidney disease and the perturbations in these cells that result in specific manifestations of kidney disease. But up until recently, with the introduction of certain new classes of drugs, we have not really made much progress in reversing kidney disease. We have found ways to make some parts better. We have found ways to delay patients going to end-stage kidney disease where they would need either renal replacement therapy through dialysis or transplantation. We have found ways to make dialysis work better. We have found ways to make transplantation more successful, but these are all late-stage technologies and don't get at the task that confronts us. How do we prevent kidney disease? How do we prevent severe and end-stage chronic kidney disease from ever happening? And the kinds of approaches that KPMP is engaged in are aimed to uncover those kinds of opportunities, targets that will lead to very specific improvements in the care of patients with kidney disease. And this is an absolutely critical question. It is very close to what I have been doing for well over 30 years. We all know that diabetic kidney disease is the single greatest cause of chronic kidney disease and end-stage kidney disease, both in the United States and worldwide. It affects people of every geography, of every social class, of every ethnicity. We currently have very limited ways that we can actually reverse the chronic changes of diabetic kidney disease. The only ones proven in people have been pancreas transplantation in a small group of patients with type 1 diabetes over a period of a decade or longer. And even this has only been demonstrated in a very small number of patients. And this is profoundly unsatisfying given the magnitude of the problem. If we can uncover similar mechanisms as we have uncovered in the mouse, or even find ways to exploit all that information that's been gained from so many studies in animal models, in various tissue culture systems, and the variety of ways that we study at a basic level diabetes and diabetic nephropathy and identify those pathways in humans and ways to target them and reverse them, I believe that we can not only treat chronic kidney disease better, but we have the potential, we can unlock the potential for reversibility. And that's my goal. And my goal is for KPMP to be successful, and that at some point down the line, maybe not in 3 years, certainly probably not 5 years, but I think within a time frame of 10 years, there are possibilities of directing therapies to achieve reversal of the commonest cause of end-stage kidney disease in the world. And that is a very meaningful goal to me, and one that keeps me actively and enthusiastically engaged in KPMP and working as best I can to achieve its success. Thank you for the chance to share all of my enthusiasms and the reasons why I'm involved in KPMP. Thank you.